y'all. Well, we're here today to do a review and test of this made in China Leaf Audio. See, what is this? It's a PA-03 Mark II. And don't think there's ever a Mark I. Never heard of this company before. I looked online, found this company in Britain that makes little DIY kits or something that's got nothing to do with this preamp. Have no idea who the company is. They don't seem to make any other products but this preamp, which it's really a nice made piece, but it looks great, but I don't know anything about it. I did stumble across a review and a test that Amir at Audio Science Review did, and he basically said this is a doorstop, wheel chock, whatever you want to call that kind of thing. It's just a decoration. It's got so much distortion. He showed some sine waves that came out of this thing at like 20 or 30 hertz or something that just looked horrible. And clearly, if that's what this thing does, it isn't usable. And so a viewer bought this, then saw the review and kind of freaked out, said, would I be willing to look at it? So I said, sure, send it to me. So we're going to run it on the scope. We're going to run it on the audio analyzer suite and see what kind of performance this one actually has. Now, this is a slightly different model. It comes with MUNDORF coupling caps, which I don't expect to make that huge a difference from what Amir saw. But it's also got an extra circuit board in it with a bunch of capacitors and caps and stuff on it that I don't know how it's even connected in here. This preamp is supposed to be a clone of an Audio Research LS22. And kind of looking at it in general, it sort of looks like it probably is. I found the schematic and stuff for that preamp. So anyway, let's get this thing on the scope, run some audio analyzer suite tests on it, and see what we're starting out with, and if this thing's worth trying to turn into something good. Okay, let's go over some of the controls here. We got the power switch here. Got a couple of VU meters, which not sure whether they are set up just to dance around to look pretty or they're actually accurate to like when the preamp starts clipping. There's our tone defeat. Got our tone controls. Here's the input selector. Here's the volume control. So let's flip this thing around and look at the back side of it. Okay, on the back we have 3 different inputs here. Then we have XLR balanced ins and outs. We have 2 sets of RCA outs, which I guess is set up to drive 2 different pieces of gear, maybe a sub and then maybe your power amp. Then we have a switch here that switches on and off the VU meter. We got a switch here that's marked AC and DC for the filaments on the heaters, I suppose. And it's not connected to anything. Well, actually, there's 2 wires going to one side of the switch, and that's it. So it's obviously not doing anything. And then here's our power connector. So let's take a look at the inside of this thing. This one is very different than the one that Amir over at Audio Science Review reviewed. This one has this extra board with a bunch of filtering caps, and it also has MUNDORF coupling caps. And I'm always suspect when I am in these made in China amplifiers are these actual MUNDORF caps. But I looked at them very closely. The fonts look right. The ink on the wrappers is kind of this weird metallic-y red, and I compared it to some legit MUNDORF caps that I have, and I think these are legit MUNDORF caps. As far as the rest of these being Nikons and stuff, they went to the trouble to get these MUNDORF caps. They're probably real Nikon caps too. Now these lower ones have Nikon on the wrappers. These don't. I'm not sure what these are. It's kind of hard to see the writing on them, but I'll see if I can see that later. But it looks like they've got WEMA caps, and I mean, it looks like some quality parts inside this thing. I am interested, though, to see how this thing performs compared to the one that Amir reviewed, because his was doing some easy to see crazy stuff on the oscilloscope. Especially down at 20 hertz, the sine wave was like super distorted. And like, while I'm not super concerned about, less than 1%, or especially if it's under 0.5% of distortion across the board, we don't want to see it spike off the rails on either end of the spectrum, nor do we want to see the frequency response be anything but flat. And so I'm curious what this thing's going to do. The other thing that I'm a little concerned about, and I'm going to have to measure some voltages and see if it's a legit concern or not, but the amplifier this is supposed to be a clone of, which is a Audio Research LS22, in these tubes it used 6922 tubes, and this has got 6 DJ8s, and they're Phillips tubes, the ones that are in this amp. And while electrically they're the same, the difference is the 6922s are a heavier duty version that deal with higher plate voltages. And the schematic is showing, at least on the plate, the voltages exceed what these tubes are rated for. But I need to measure the cathode voltage to see if it's actually across the tube too high, because that's what matters. I mean, you could have 200 volts on the plate, but if you got 100 volts on the cathode, you've only got 100 volts across the tube. And so we're going to be checking that stuff out too. But the first thing I want to do is hook this thing up to my oscilloscope and start looking at waveforms, square waves, sine waves at different frequencies, and see how this thing reproduces them. Okay, so we've got the preamp all warmed up. Been running for about 15 minutes. We got our Tektronix 2235 analog scope along with our 10-mont audio generator connected. All analog test gear, which I like using with analog audio gear. But anyway, this waveform on the top is coming out of the signal generator, and this is a 1K signal. We're running it on 1 volt per division on both channels. Second channel is hooked up to the output of the preamp. As you can see, we're running 3 volts peak to peak sine wave in, which is about 1 volt RMS, which is kind of a balance between what a modern source would be and maybe what a slightly weaker source would be. So that's kind of where I test most of my audio gear, is with that signal, but we'll go ahead later and try it at 2 volts RMS just to make sure that doesn't overload this preamp. So first I want to just see what this sine wave looks like, and this is interesting. There's a little over 3/4 volume, and that's basically unity gain, which honestly, for how most people would use this preamp, that's a good thing. From what I've seen, most people are wanting to use a preamp on solid state gear that probably doesn't really need a preamp, that has enough input sensitivity where the normal signal out of your DAC would just drive it straight out of the DAC. But they're looking for some tube gear to put between a digital source or maybe even a turntable with a solid state phono stage and a solid state amp to add some warmth or tube sound to their system. So I will say right here, again, this is almost unity gain. So you can see the potentiometer is one of these click types, so it's hard to get like right where I want it to be. But even there, at 3/4 volume, the VU meter is reading plus 3 dBs when it in fact is a little less dBs than what's coming in, or a little less signal. And so the VU meters seem to be not really calibrated to show you like exactly how much gain you're getting out of this preamp, but they're probably more for decoration, which is what most people want them to do anyway. When I've worked on amps that had VU meters that were accurate, people complained they didn't move enough. And so this is probably a good calibration for what people are going to be actually using VU meters for, and it's strictly just for appearance. So anyway, let's get on with the testing. I'm going to test it at this setting here, which is just past unity gain, and then let's see what it does at different frequencies. I know Amir was saying that at low frequency the sine wave went crazy. So let's see if this higher end version does the same thing. And there it is at 100 hertz, and honestly, I'm not seeing any distortion to speak of. I mean, that signal, and I wish I could have a finer tune on this volume knob to get it where they would lay right on top of each other, but unfortunately it doesn't. So you can still see, though, the shape of the sine wave is identical to the one coming in. So let's go down to 20 hertz. And this is where the one that Amir tested went crazy. And they look the same to me. I'm just not seeing the mega distortion in the sine wave that the sample he tested had. So either this higher spec one resolves that problem, or the one that he tested, there was something wrong with it. Maybe it had a bad tube, or I'm not sure what may have been going on with it. But 20 hertz looks fine to me, the sine wave anyway. Let's jump up to 10K. And let's see what this looks like. Okay, here's our 10K sine wave. And again, I'm not seeing a distortion of the sine wave. The shape of them looks the same to me. So at least this sample passes that test with no problem whatsoever. So let's go back to our 1K setting and start looking at some square waves. And we're going to start off with the tone defeat button out, which means the tone knobs should have no effect on what we're seeing on the square waves. Okay, so I'm not seeing the same joy here. I'm seeing the roll off on the high end, and then the bottom end isn't bad, but it's not exactly what I would want to see. You can see how it rolls off on this end. The interesting thing I discovered with the tone defeat button in, if you turn up the treble and the bass all the way, it flattens out the square wave. Now, obviously it shouldn't be doing that, but if you have one of these preamps and you want to use it in the tone defeat mode, make sure you turn both of the tone knobs fully clockwise when you have the button turned in, and you're going to get a nice flat square wave out of this preamp. So let's go down to 100 hertz, see what the square wave looks like there. Okay, so here it is on 100 hertz, and I'm not surprised to see the bottom end rolling off a little bit like this. This isn't uncommon on a tube amp, and I'm sure when we put it on the audio analyzer suite, we're going to see it, roll up a few dB on the bottom end as it comes up to the frequency response curve. But we'll see that better on the audio analyzer suite when we run that on it. And so let me lower the frequency down. There's 40 hertz. And we see it even more pronounced. But that doesn't really shock me. But a lot of my amps that I've built show this when you go down on a square wave into the lower frequencies testing it. And that doesn't concern me at all. So let's go see what it does at 10K. Okay, at 10K, we do have some ringing on the top end, but That's not unusual either. And honestly, I would rather see a little bit of ringing like this than have it like just roll off and be flat. When I've tuned amps where they have the square wave where this front end just rolls off and is flat, they sound totally dead and lifeless. So I would much rather see this, but I'm not seeing like uncontrolled oscillations where the preamp's unstable. If it was, this would just keep going all the way across. So here we are at 1K again, and as you can see, when we turn the tone knobs, it has an impact. That's straight up. If you turn them fully counterclockwise, it's definitely affecting the tone curve. And to really be neutral, they need to be turned all the way to the right. Now let me turn off the tone defeat and show you. There's boosted bass, there's low bass, there's cranking up the treble, and there's turning down the treble. And see, I wonder if when Amir was testing this and had it on tone defeat, if he had the knobs straight up, you're not going to get a flat frequency response curve. I get it, I know it should, but testing these square waves has shown me that's not the case. So when I'm doing the frequency response curves on the audio analyzer suite, I'm going to have the defeat button turned in with the knobs all the way clockwise that showed a nice flat square wave, and I think we probably are going to get a decent frequency response, and then we'll test it again with them straight up and see if that is maybe what Amir saw when he was testing this. So the last thing I want to show you is this preamplifier is capable of more than unity gain if that's what you need, and right now we're at just over 3/4 volume, and each of the adjustments is at 1 volt per division. And as you can see, we got same signal coming in, coming out. We turn the volume all the way up. Then we need to change it to 5 volts per division to get the same output. So let's measure this. If we've got 2 volts peak to peak coming in, we got 10 volts peak to peak going out, and that's into a 50K load. So I think we've done enough here on the scope with the signal generator, looking at square waves and stuff. I got a good kind of handle on what this amp's capable of. So I think that's enough of this signal generator and scope testing. I've got a pretty good handle on what this preamp's capable of, and what I'm seeing so far looks really decent, if not very nice. And again, I haven't listened to this thing. I wanted to do this testing first and then see what this thing sounds like hooked up to my system. So let me get the audio analyzer suite hooked up and let's see what kind of information we can get from that. So we're fixing to do a THD versus power pull on this Leaf Audio preamplifier. And when I'm working on a preamplifier, up here you would set the range for, starting down low up to however many watts you're expecting with the load impedance set here, and the software calculates up what the curve looks like and stops and maps it out by watts. But we're not doing that on a preamp. What we're going to use instead is this down here. We set it down to 100 millivolts to 1 volt RMS, and that's the range it's going to sweep across. We've got THD set. We got THD set at 5% in case things go crazy. We've got channel 1. We're going to check just the THD, and we have the volume set on unity gain so we can sweep the whole range here, which is about 3/4 volume. And we're down below 0.1%. We just went past 0.1%. And then, as you can see, this is pretty unity gain. There's the input is 0.9 volts RMS and the output's 1 volt RMS. So you can see it 1 volt RMS out, we're at 0.215% distortion, which you're never going to hear that. So on this graph, I did this pull earlier. This is the THD versus frequency. and below you can see the harmonics down in this window down here. And down at 20 Hertz, we've got 0.2% distortion, and it stays down there below 0.1% distortion across the range here. And that's pulling at 0.5 volts RMS. Last thing we want to look at is the frequency response. And let's pull this at 0.5 volts RMS too. And this is looking very flat. Now again, this is with the tone defeat and both the knobs turned all the way clockwise, which we saw on the oscilloscope gave us our nice flat square wave. So out of curiosity, I'm going to put it with the tone defeat with the knobs straight up and see what that shows us. So as you can see, those tone knobs have an effect even with the tone defeat button pushed in. So if you're going to run this thing with the tone defeat, make sure you turn the knobs all the way clockwise, and then you'll get a flat frequency response out of it. Okay, I know it's not supposed to do that, but that's just the reality that this amp has. And I'm not sure if that's some of what Amir was seeing. The other thing is I think he was driving this thing much, much harder than it would ever see in actual use, the way this preamp would be used by 90% of the people that are using it. I'm also not testing the XLRs, I'm testing the RCA jacks. But again, with the tone defeat on and the knobs turned all the way up, that's as flat a frequency response as you're probably ever going to see out of a tube anything. As we're starting down here at 20 Hertz and just all the way across there, past 30K, it's totally flat. So I'm not seeing anything wrong with this amp. I mean, I know the other one that Amir tested, I'm not sure if it was based on that it was using the XLR inputs or what the actual issue was, or whether it was being overdriven just into distortion and it's going past what this thing's capable of actually doing. One thing else I want to do real quick is I want to pull this again and watch the VU meters and kind of note where they are on the scale. That's 0. And that was +3 on the scale right here at 0.25% of distortion. So maybe these VU meters are useful. If you're starting to see them past the 5, you're pegging out the VU meters, you're probably clipping and overdriving this preamp into distortion. And as long as you, especially if you stay in the black range, it's going to be down at 0.1% distortion. So maybe these VU meters are doing more than I was giving them credit for. So I want to do one last test here. I'm going to hook this thing back up to my scope and see at what point overdriving it makes it start clipping. So let me do that and I'll report back on what I find on that. Okay, so I did put this thing back on the scope with the signal generator to see how far I had to push it to get it to go into clipping on the sine wave, which is a sign of just unusable power. And this thing has to be pushed really hard. I was pushing like 10 volts RMS on the input and getting 45 volts out before I started seeing clipping. And given that most sources are 2 volts RMS at the most, you're not going to be able to drive this thing into distortion with a normal load. So it's not anywhere near clipping. So you don't have to worry about that with this unit. So how did it sound? Well, I hooked it up to my system, and with the tone defeat and the knobs turned over like I showed you in the testing part, it sounds very neutral. Wasn't doing a lot of tone shifting or anything weird. I didn't hear any distortion. It sounded clean, and it's doing what a preamp like this was made to do. So what is this preamp made to do? These things harken back to the day of when the normal sources were maybe a quarter of a volt RMS, and the amplifiers needed 4 to 5 volts RMS to drive them to full power. The amplifiers didn't have any controls on them. They were just like a brick with a power switch on them, you know, with the RCA jacks and an output for the speakers. And then you needed something like this to slightly elevate the signal, but also provide a volume control and input selectors and tone controls and that kind of thing that you might want in your system. And that's what this thing does very well, I think. And this is also a tube device, and you can see with the second harmonics are definitely there that you want to see, that give it that warmth that you get out of a tube sound. And I think putting something like this between a digital source and a solid state pair of power amps would work really well. But most amplifiers today are integrated amps that have a volume control and source select and all that kind of stuff. So you really don't need a preamp to have a usable system. And especially if you have a nice sounding tube amp that has controls and stuff on it, there's really no need to insert something like this in the signal path between like your phono stage and the amplifier, or the DAC in your amplifier. Now, I could see adding something like this into a solid state system if you are looking to try to insert some of that tube sound into your system. So that's kind of where this thing fits into the whole spectrum of stereo gear. Now, I know these things are really popular, and a lot of people, you know, have some really nice sounding tube amp, like maybe one of those Wilsonton R8s, or, you know, something like my 300B amp, and then they feel like, oh, well, I want to put another piece of gear in. And I just honestly don't think that's a good idea. I know it's real popular, and this may not be a popular thing to say, but guys, I think you're making a mistake. You're just adding stuff in the signal path that isn't necessary. And so somebody said to me, Skunky, I'm going to give you this preamp. Would I put it in my system? No. I listened to this thing back and forth between this being in the system and then hooking the cable straight from my phono stage to my 300B amp, and then putting this in the system and pulling it out. And it wasn't like it was night and day. It was a very, very, very subtle difference. But you could just tell there was a little bit of clarity missing. The cymbals just were a little less sharp. And I can believe that because you're running the signal through 2 more tubes, which is 4 triodes. You're running it through 2 more coupling caps before it gets to the amplifier, which aren't necessary. And so I found the same thing when I tried that little shit Loki box that a lot of people rave about. It's a little digital sound tone control box that you can put between your source and a tube amp. And people are saying, oh yeah, you don't need a tube roll anymore. You can just adjust this little box and do everything that tube rolling would do. Well, every time I would switch it in and out of the system, I could hear that clarity, that little veil getting lifted off the sound when I removed it from the system. Because you're just putting one more thing in the signal path. And so, I guess what I'm saying is, if you really have a need for a preamp, or you have a solid state system and you want to give tube stuff a try, this might be a good option. So anyway, hope you enjoyed this review and test. Hope you're enjoying the content on my channel. If you are, Please subscribe. Please like the video. Until the next project, have a nice day.